Question 4 is all about business management, essentially. We're given a cost function for a small company which makes X machines each month, and we're also given an income function in dollars for the amount of money they get from selling those machines. And we're asked to show that the profit function can be expressed like this. So essentially we need to understand that profit is going to be your income less your costs. So we can take the income function, which is 150x minus 0.6x squared, and subtract the cost function, which is 2,600 plus 0.4x squared. So when we expand that, that's going to be 150x minus 0.6x squared minus 2,600 minus 0.4x squared. So if we look at the x squared, that's going to be minus x squared plus 150x minus 2,600, which we can then check is the same as the profit function which we have been provided with. In part B, it says the maximum profit occurs at the vertex of the function px. How many machines should be made and sold each month for a maximum profit? The easiest thing to do here is just to graph this function. If you put the function here into your calculator, you want to identify the vertex here. So second calc, max, and identify the vertex, and you're interested in the number of machines, so that's the x-coordinate. And if you do that, you'll find that the x-coordinate for that is 75. The other way you could do this is using the line of symmetry. So we could find the line of symmetry because we know the formula for that is x equals minus b over 2a. B is the coefficient of the x term, which is 150. So that would be minus 150 over 2a. A is the coefficient of x squared, which is minus 1. So that would be minus 150 divided by minus 2, which also gives you 75. Parts C and D are a little bit trickier. So we know from part B that we can maximise the profit when the number of machines is 75. And then part C says, well, if the company does maximise profit, so if it does produce 75, what is the selling price of each machine? So we can find the selling price because the selling price is found using the income. So that we know that if we sell 75, the income from 75 will be 150 times 75 minus 0.6 times 75 squared. So the income will be $7,875, but that's from 75 machines. So we need to divide that by 75 to find the selling price of each machine. And if you do that, that will give you an answer of $105. In part D, it says, given that a profit function is x minus 20, 130 minus x, find the smallest number of machines the company must make and sell each month in order to make positive profit. So just looking at this, the easiest way to think about it is to graph it. So you could either expand the brackets and then just type that into your calculator. Or you might be able to recognise that if we've got x minus 20 and 130 minus x, if you just look at the first bracket, I can factor out minus 1, and that's going to leave me with x minus 130, and then my second bracket is x minus 20. When it's in intercept form, we should be able to just recognise what this graph is going to look like. From the negative sign at the front, we know it's going to be upside down, and it's going to pass through 20 and 130. So it's going to look something like that. So anywhere in this green section here, the profit is going to be greater than 0. On the actual intercepts, the profit is equal to 0, therefore we wouldn't be making a positive profit. So we know that when they're making 20 machines, the profit is 0, so it's not positive, therefore it's got to be greater than 20, so the first number of machines where they will make a positive profit, therefore, is 21.